Hello dear viewers, this is AI Voice Gary, speaking to you as Buddy from Town's narrator. Since Buddy began his exploration of the cosmos, he has become interested in current news about the universe. Today, Buddy from Town is sharing news about a group of astronomers, who produced the most comprehensive image of radio emission, from the nearest actively feeding supermassive black hole to Earth. The article, Astronomers Capture Black Hole Eruption Spanning 16 Times the Full Moon in the Sky, was posted on the International Center for Radio Astronomy Research website, on December 23, 2021. The research has been published in the journal Nature Astronomy. Centaurus A is the closest radio galaxy to our own Milky Way. Centaurus A is a giant elliptical active galaxy, 12 million light-years away. At its heart, lies a black hole with a mass of 55 million suns. Now, astronomers have produced the most comprehensive image of radio emission from the supermassive black hole. This image shows the galaxy at radio wavelengths, revealing vast lobes of plasma that reach far beyond the visible galaxy, which occupies only a small patch at the center of the image. The dots in the background are not stars, but radio galaxies much like Centaurus A, at far greater distances. It was captured using the Murchison Wide Field Array Telescope in outback Western Australia. MWA Director Professor Stephen Tingay said the research was possible because of the telescope's extremely wide field of view, superb radio quiet location, and excellent sensitivity. Lead author, Dr. Benjamin McKinley, from the Curtin University node of the International Center for Radio Astronomy Research, said, "The image reveals spectacular new details of the radio emission from the galaxy. These radio waves come from material being sucked into the supermassive black hole in the middle of the galaxy," McKinley explains. "It forms a disk around the black hole, and as the matter gets ripped apart going close to the black hole, powerful jets form on either side of the disk, ejecting most of the material back out into space, to distances of probably more than 1 million light-years. When viewed from Earth, the eruption from Centaurus now extends 8 degrees across the sky, the length of 16 full moons laid side by side. This composite image shows the galaxy, and the surrounding intergalactic space, at several different wavelengths. The radio plasma is displayed in blue, and appears to be interacting with hot X-ray emitting gas, orange, and cold neutral hydrogen, purple. Clouds emitting alpha, red, are also shown above the main optical part of the galaxy which lies in between the two brightest radio blobs. Dr. McKinley says, "We can learn a lot from Centaurus A, in particular, just because it is so close, and we can see it in such detail. Not just at radio wavelengths, but at all other wavelengths of light as well. In this research, we've been able to combine the radio observations with optical and X-ray data, to help us better understand the physics of these supermassive black holes." Astrophysicist Dr. Massimo Gaspari, from Italy's National Institute for Astrophysics, said the study corroborated a novel theory known as chaotic cold accretion, CCA, which is emerging in different fields. Dr. Massimo Gaspari says, "In this model, clouds of cold gas condense in the galactic halo and rain down onto the central regions, feeding the supermassive black hole. Triggered by this rain, the black hole vigorously reacts by launching energy back via radio jets that inflate the spectacular lobes we see in the MWA image. This study is one of the first to probe in such detail the multi-phase CCA weather over the full range of scales," Dr. Gaspari concluded. Dr. McKinley said, "The galaxy appears brighter in the center where it is more active, and there is a lot of energy. Then it's fainter as you go out because the energy's been lost, and things have settled down," he said. "But, there are interesting features where charged particles have re-accelerated, and are interacting with strong magnetic fields." So, how big are black holes? NASA explains, black holes can be big or small. Scientists think the smallest black holes are as small as just one atom. Scientists think the smallest black holes, primordial black holes, formed when the universe began. These black holes are very tiny but have the mass of a large mountain. Another kind of black hole is called stellar black hole. Its mass can be up to 20 times more than the mass of the Sun. Stellar black holes are made when the center of a very big star falls in upon itself, or collapses. When this happens, it causes a supernova. When a larger star collapses, it continues to compress and creates a stellar black hole. Black holes formed by the collapse of individual stars are relatively small, but incredibly dense. One of these objects packs more than 3 times the mass of the Sun into the diameter of a city. This leads to an immense amount of gravitational force pulling on objects around the object. Stellar black holes then consume the dust and gas from their surrounding galaxies, which keeps them growing in size. In 2015, astronomers using the Laser Interferometer Gravitational Wave Observatory, LIGO, detected gravitational waves from merging stellar black holes. David Shoemaker, the spokesperson for the LIGO scientific collaboration, said in a statement, "We have further confirmation of the existence of stellar mass black holes that are larger than 20 solar masses. These are objects we didn't know existed before LIGO detected them." LIGO's observations also provide insights about the direction a black hole spins. As 2 black holes spiral around one another, they can spin in the same direction, or in the opposite direction. The largest black holes are called supermassive. Scientists think supermassive black holes were made at the same time as the galaxy they are in. These black holes have masses that are more than 1 million suns together. Scientists have found proof that every large galaxy contains a supermassive black hole at its center. Supermassive black holes may be the result of hundreds, or thousands of tiny black holes that merge together. Large gas clouds could also be responsible, collapsing together and rapidly accreting mass. A third option is the collapse of a stellar cluster, a group of stars all falling together. Fourth, supermassive black holes could arise from large clusters of dark matter. This is a substance that we can observe through its gravitational effect on other objects. However, we don't know what dark matter is composed of because it does not emit light, and cannot be directly observed. Intermediate black holes. Scientists once thought that black holes came in only small and large sizes, but research has revealed the possibility that mid-size, or intermediate black holes could exist. Such bodies could form when stars in a cluster collide in a chain reaction. Several of these intermediate black holes forming in the same region could then eventually fall together in the center of a galaxy, and create a supermassive black hole. In 2014, astronomers found what appeared to be an intermediate mass black hole in the arm of a spiral galaxy. And, in 2021, astronomers took advantage of an ancient gamma-ray burst to detect one. Astronomers have been looking very hard for these medium-sized black holes, study co-author Tim Roberts of the University of Durham in the United Kingdom, said in a statement. There have been hints that they exist, but intermediate black holes have been acting like a long-lost relative that isn't interested in being found. This concludes Buddy's Space News today. If you would like to follow along to see Buddy from Town become Buddy of Singularity, please click subscribe, and a like would be appreciated. Until next time, dear viewers, keep looking up and looking back, way back.